Hello, this is 3rd of November 2024. Today is a financial engineering class. Uh, in financial engineering, there's a lot of important topic that I'm going to briefly introduce today. First, mm, first topic will be mm, first topic which is important will be uh if you deposit the money, how much will you get? This is important. This is related with engineering economy. In engineering economy class, we will discuss again in a very topic. There can be you will learn if you put the money here, then N years later, how many money will you get when interest rate is 10%? You can calculate it very simply. And you should also calculate about compound period and payment period. By this, there will be a various type of differences. The compounded can be annually, quarterly, monthly, or continuously. And payment will be also, there can be various of type. And basic financial engineering, you need to be able to calculate moment generation function and some CDF function, because later Blackscholes and other functions are come out, and it is basically or continuous. It is very basically or kind of the static sticker function. And for people's belief of change of price can be also, we can represent it in stochastic calculus. Maybe it can be ft equals to ft minus 1 plus wt, which will be kind of variance. We can make this formula and we can solve it by set maybe w1, 2, 3 is identically distributed, and maybe it follows normal distribution. And in engineering economy class, you will also learn about what is IRR, which is when there's input and output, what is the interest rate that will make zero. You will learn it, and you can also calculate it with some function, maybe polynomial function. With polynomial function, you can calculate it. If currently, do you have any questions?
No, we don't.
Okay, I will go ahead. So this is very important in financial engineering, and maybe there can be another situation. This kind of thing will be also applied on calculating bond. When you calculate bond, then there will be bond price. There will be 4% for bond for maybe 3 years. Then you will calculate there is initial price and there will be 4%. Then there will be another 4%, 4%. Then there will be after 4%, there will be some price. There will be some price again. There will be some price coming, and there will be some ending price come out. So you should match the price to calculate the bond prices. This is kind of important topic in introduction of financial engineering. And you should also able to calculate about when given S&P 500 is given, to calculate about what you should be able to calculate or derive value of swap. This can be also modeled with some SI and DI. This will be also important. Let's quickly go further. And if you filter Go, then you will learn about GBM model, which is geometric Brownian motion. This is very important. You'll be able to calculate some option prices, and it is kind of approximate version of Blackscholes model. You can calculate a price of American call option with strike price and maturity year. And like I said before, Blackscholes we will discuss later, but there is normal distribution. Some normal distribution is we can represent it with normal distribution. So it is very important to calculate functions that normal distributions is input. And there will be some gambler's formula and Monty-Hall problem maybe. It is also such probability topic is important for financial engineering. And there will be forward equations you should be able to calculate. And forward equation, there will be a lot of state price. You should be able to calculate how much is zero coupon price when face value is 100. And maybe another problem can be given term structure. What is coupon price or how much coupon I pay annually? This can be the problem given. A GBM is linked with stock binomial lattice model. In binomial lattice model, there will be probability assumed measure. We take it as 0.5 in ideal situation, but in reality, it is different. So there will be different rate. It is important to calculate how much is it, and also about how much it goes up and how much it goes down. We should also we should calculate it, and we usually calculate it with backward induction method. I will discuss it deeply later. And also we assume about arbitrage, and we will check it satisfies martingale. And if we go deeply here, we can meet couplet, which is second derivative product, and we can maybe make a problem such as given spot forward rate, calibrate the model or recalibrate the model. Swaption and calibration is also a very important issue. And if you go further, you will learn about CDM, which is one of the model important in financial engineering. And you should be able to calculate Blackscholes model. It is actually able to represent with two normal distribution. So I hope you want to try it. And stock price and standard deviation. Given standard deviation, how much will be price option strike price? This kind of problem set is very important topic. And when you hedging, there is Greek hedging, delta hedging, and gamma hedging. Delta is about the sensitivity of respect to time t, and hedging is very important topic. It will be related with dynamic replication and also about portfolio rebalancing, maybe self-financing trading strategy, which is there is no cash flow input output. And you should also maybe calculate about you should be able to make a model such as in given binomial situation. If we say there's arbitrage opportunity, if initial basic asset goes up and when basic asset portfolio goes down, there will be some delta which makes price equally. Then you will be able to really hedge the thing. It is very important thing in hedging. And we can maybe set volatility as variables or constant. Based on that, there can be some differences. Maybe if sigma expectation of sigma is bigger than sigma of expectation, it can be convex or concave. This kind of notion is come out in financial engineering. Next time, I will go deeper financial engineering.